Hey, what's up everyone? Welcome to Stoichiometry and Solutions Part 5. Today is all about percent composition by mass. So percent mass, percent composition by mass, they're all kind of the same thing. It's just a representation of the concentration of an element in a compound. And you're going to have, I guess, two different types of mass percents. They're very, very similar, but the first one is going to be the mass of an element divided by the mass of the compound. So if this was kind of like an equation, it would be the mass of the element over the mass of the compound times 100%, because after all, this is a percent that we're dealing with here. So I guess to practice this, let's find all the mass percents of all the elements in C2H6N2. The first step is to assume you have 1 mole of that substance. So if you have 1 mole of C2H6N2, what's the mass of your compound? The mass of the compound is going to be the molar mass. And the molar mass of C2H6N2 is 58 grams. Okay, so what's the mass of the carbon? What's the mass of the hydrogen? What's the mass of the nitrogen? Okay, so let's try to find the mass percent of the carbon. Carbon has a molar mass of 12, and since you have 2 carbons, the mass of your element is going to be 24 grams. And if you divide that by 58 grams, and multiply that by 100%, the percent mass of carbon comes out to 41.3%. And that's carbon. Let's do hydrogen. So hydrogen has a molar mass of 1, but you have 6 hydrogens, so it's 6 grams over 58 grams. Again, it's the mass of the element over the mass of the entire compound. And you multiply that by 100%, and that gets you about 10.3%. Let's do the last one, which is nitrogen. So nitrogen has a molar mass of 14, and we have 2 of it. So 28 grams over 58 grams times 100% is 48.3%. So your final set of answers is that C2H6N2 is 41.3% by mass carbon, 10.3% by mass hydrogen, and 38.3% by mass nitrogen. Now, if you notice, all these percentages add up to 100%, and that should make sense. All your mass percents of an element should equal 100%. So if you do some calculations and you realize at the end all of it doesn't add up to 100%, or very, very close to 100% with rounding, then something went wrong and you should check your work again. All right, let's look at the second type of mass percent, and that is going to be the mass of the solute divided by the mass of the solution. So I guess the first one was more to deal with an element in a compound, and this one is more to deal with solutions. So let's do a practice problem. Find the mass percent of 12 grams of sodium chloride dissolved in 100 mils of water. So it's mass of solute over mass of solution. The solute that we have here is the sodium chloride. And we're told that we have 12 grams of it, so that part is really easy. The bottom part is going to be the mass of the solution. We know that 12 grams of sodium chloride is dissolved in 100 mils of water. How much does 100 mils of water weigh? Well, water has a density of 1 gram per milliliter, so 100 milliliters is going to be 100 grams. But the solution isn't just 100 grams. The solution is the water and the sodium chloride. So to this figure, to 100 grams, you have to add the 12 grams of the sodium chloride, and that's 112 grams. So the denominator is 112 grams. That's the mass of your solution, and you multiply this figure by 100%. That'll come out to about 10.7%. So this solution is 10.7% sodium chloride by mass. As far as questions that use mass percentages, there's going to be 2 different types, or generally 2 different types. The first one is a bit more straightforward. We're asked which hydrocarbon is 84.1% carbon by mass, and we're given 4 options. So for all of these, we're going to need to find out what mass percent is carbon. So let's start with CH4, methane, CH4. Mass percent is going to be the mass of the element over the mass of the entire compound. So if we have 1 mole of this compound, carbon is going to take up 12 grams, and the total mass is going to be 16 grams. That's the molar mass. And we multiply this number by 100%, and you realize carbon is 75% in this compound. So clearly CH4 is not our answer. What about the other ones? Let's try C2H6. Carbon in this case, if you have a mole, is 24 grams. Over the molar mass of this compound is 30 grams. And you multiply this number by 100%, and that tells you that carbon is about 87%. That's also not 84.1%, so this is also not the answer. Let's do C4H10. In a mole, carbon is going to be 48 grams. Over the molar mass is 58 grams. Multiply this number by 100%, and that is 82.8%. That is also not 84.1%. So by default, it has to be D, but let's make sure. So D is C8H18. If you have a mole, carbon is going to take up 96 grams over the molar mass, which is 114 grams, times 100%, and that's right about 84.1%. So there you go. Your answer is C8H10 or D. And that is the correct answer. The other type of question that you might get is something like this. So the middle in our guy is 48.41% copper, 19.02% arsenic, and 32.57% sulfur by mass. What is the empirical formula of enargite? So we're asked to use the percent masses and use that to determine the chemical formula. For questions like this, it's really helpful to just assume an initial mass. So let's say initially the mass is 100 grams. What this means is that 48.41 grams of that is going to be copper. And this is coming from the fact that 48.41% of the compound is copper by mass. And then 19.02 grams of arsenic, and we have 32.57 grams of sulfur. Now, how do we use this information? Remember, empirical formula is just a ratio of the number of moles, really. So we're going to need to convert from grams to moles. So to convert from grams to moles, we need to divide by the molar mass. So copper has a molar mass of 63.5 grams. And so you have 0.76 moles of copper. Arsenic has a molar mass of about 74.9 grams. And so that comes out to about 0.25 moles of arsenic. And sulfur has a molar mass of 32.1 grams. So that's about 1.01 moles of sulfur. Okay, so empirical formula is a ratio. So the ratio that we have currently is 0.76 copper to 0.25 arsenic to 1.01 sulfur. But if you realize that not all of these are integers, and we are going to need integers if we're talking about a chemical formula. So how do we take these and turn them into integers? Well, the first thing that you want to do is you want to divide all the numbers by the lowest number that we have here. And the lowest number that we have here is 0.25. So let's divide this entire ratio by 0.25. And when you do that, most of your problems go away. So the new ratio that you have is about 3 copper to 1 arsenic to 4 sulfur. So that means your empirical formula is 3 copper, copper 3, arsenic S4. That is your empirical formula, and that is answer choice C. And that is the correct answer. Okay, so again, for questions like this where you're given percent masses and asked to find empirical formula, it's really helpful to assume a certain mass. And the mass that you really want to use is 100 grams, because then you don't really have to worry about taking the percentages and converting it to mass. Instead, if you have 100 grams, then the percent and the mass is just going to be the same. So you take that mass and you divide by molar mass to get the moles, and then you use the ratio of the moles and you convert them into integers to get your empirical formula. And that's how you solve problems like this. That's it for percent composition by mass. I hope you were able to learn something, and I hope to see you later. Thank you.